All right, Dave, no clapping this time. All right. Oh, we're live. 5-2, day 2. We're continuing from what we talked about yesterday, and we are going to add in topics of minimum and maximum. So the vertex is a minimum or maximum, and then we're going to revisit domain and range. So let's just throw a little bit of information out there as far as what those mean. So if we have a minimum situation, yeah, there we go. All right, so if we have a minimum vertex, so if the vertex is a minimum value, is that going to be a situation where this graph opens upward or downward? Upward. Good. Yep. So if the graph opens upward, then my vertex is going to be a minimum. And on the flip side of that, if the graph opens downward, then the vertex is going to be a maximum. Good. All right. Okay. Then when we talk about domain and range, hopefully you remember a little bit from the beginning of the year that the domain is all the possible x values. So all possible x values. We also referred to the domain as the input, or the domain as the independent variable. Okay, so basically when we think of domain, we think of x values, possible x values. When we think of range, we think of possible y values. All right, so we're going to talk about what the domain and the range of each of these quadratic functions are. Okay. Next page has a question from yesterday, so this is just a review question. So here's what we did yesterday for those of you that may have been gone. We have a function f of x equals negative 2x squared minus 4x, and we want to determine whether that opens up or down. We need to find the axis of symmetry. We need to find the vertex and the y-intercept and graph it. So does this open up or down from what you learned yesterday? Opens downward. And you know that it opens downward because the leading coefficient, which is my a value, is negative. So that is going to open downward. And the reason being is that my a, so if I have my standard equation ax squared plus bx plus c, if the a value is less than 0, it opens down. If the a value is greater than 0, it opens up. So that one opens downward. We have a axis of symmetry that goes through my vertex of the opposite of b over 2a. So the axis of symmetry is always the opposite of b over 2a. In this case, the opposite of b is, well, here, let's just list our a, b, and c values quick. So a is negative 2, yep. B is good, negative 4. C is, yeah, 0, good. So opposite of b, opposite of negative 4 is positive 4 divided by 2 times negative 2, which is going to be negative 1. So x equals negative 1 is my axis of symmetry. What that means is that's the line that goes through the vertex that cuts our parabola in half symmetrically. So my vertex is somewhere on that vertical, imaginary vertical axis. Where is it on that axis? Well, we can just take our value, negative 1, because now I know my x value of the vertex. The x value of the vertex and the axis of symmetry are the same, so that's negative 1. And so now I want to find what is f of negative 1. That's essentially the y value of my vertex, so I got to plug negative 1 into the function. So if I put negative 1 into this function and I evaluate, what is f of negative 1? I'm going to get 2 times negative 1 squared minus 4 times negative 1, which ends up being, I think, oh, sorry, I forgot a negative. Negative 2 plus 4, essentially, which is a negative 2, right? Negative 2, yes, positive 2. Did I say negative? Positive 2, thanks. Okay, so we have a negative 1, 2 is my vertex. So that is the point on this axis where the vertex is. So I go to on my little axis of symmetry, and I go up to positive 2, and that's where my vertex is going to be. My y-intercept, that's the D. So what is my y-intercept? We know that at the y-intercept, we know x is 0. So when I put 0 in for x, I get 0 out for y in this case. Or my constant, my c value is 0, so I know that that's my y-intercept. So if that's a point there on the other side of the axis, because it's symmetrical, is another point. And from there you can make a nice little happy sketch. Actually, it's a frown sketch. Nice little sad sketch. Bob Ross would not like this. Oh, it's just, that's actually a pretty doggone good looking parabola there. So that's what we did yesterday. How do you feel about that? Muy bien. Okay. Let's keep trucking along here. So now back in vertex form. However, this first one's like, really? Is that really in vertex form? I mean, I don't know. This might be, this looks a little, all right, what if I write it like this? What if I go f of x equals x minus 0 squared plus 5? Then some of you are like, oh, yeah, that's in vertex form, yeah. All right. You know, this one's kind of could go either way. It could be like, yeah, that's vertex form. Or like if I wrote it like this up here, and I wrote it x squared plus 0x plus 5. Some of you are like, oh, yeah, that's in standard form. Yep. So really, it's kind of like, could be both. But either way, it does have a vertex, which is a minimum or a maximum. So in this case, if I list the vertex is going to be 0, 5. So my vertex is 0, 5. And so is that going to be a maximum or a minimum? Well, this one's going to open, this one opens upward. So because it opens upward, then my vertex is a, and it might help you even to draw that in there. You might want to just draw it in. Opens up, oh yeah, it's going to be a minimum. So my minimum value then is going to be the y value of the vertex. That is my minimum. And it's a minimum because it opened upward. So the minimum value, you would say, is y equals 5. I don't want to put that double equal there. I don't like that. That's kind of dumb. So the minimum is y equal 5. What's your question? How do you know that it's a minimum? So like, yeah, this question came up too last hour, so that's fine. So like, let's just say here you're this little dot here, right? And you're following along the parabola, okay? Because these arrows are pointing upwards to the sky, there's no like maximum. It just keeps going forever, up and up and up and up and up and up, and then I'm gonna go off the graph there, see? But if I'm following it down, in this case to the right, I'm going to get to an absolute minimum point right there. And then I start going up and up and up and up and up forever. So there is no maximum, but there's only a minimum. Does that make sense? And if it were flipped upside down, so if I were to take this and if I were to rotate that, now all of a sudden we're talking about it not having a minimum point, but a maximum point. Kind of like roller coaster, and then you go down, right? So this has a maximum. Natalie? For this one, since it was in vertex form, I found, I found the vertex by just looking at the equation and determining that, you know, my vertex goes 0 to the, whoa. Now we're having a lot of fun here, guys. Whoa! Okay, this is on video. Let's be professional. Oh my gosh, I didn't try to do that. Wow, we're really having fun now. Okay, so in vertex form, like it goes 0 to the right. Don't you remember that from last unit? And then 5 up. So just from that transformations unit, remembering that. So over here, now I should be able to look at this function and say, okay, what's the vertex? The vertex is 3, -2. Good. And is that vertex a maximum or a minimum? I forgot about domain and range. I'll go back and do that after this. So domain, or I'm sorry, this one is opens downward, and it opens downward because that is a -a, so there's a negative out in front. And so because it opens downward, this vertex point is going to be a maximum, and the maximum is going to be in regards to the y value. So the maximum is y equals -2. Y cannot become any larger than that value. All right? Thought I saw a hand go up in the back. Yeah. The minimum or the maximum will always be a y value. Yep. Because x doesn't have a, I mean, you can say it's a minimum at x equals 0, but the minimum actually refers to the y value. Good question. And in fact, Dave, there is a caution on that on the next slide, which I also was thinking maybe you could read for us. So, so here, let's have you.
All right. Oh shoot, I'm turning down the volume. Caution! The minimum, or maximum, value is the y value at the vertex. It is not the ordered pair that represents the vertex.
All right, well done, Dave. We've had 3 people read that today. We had Riley Ledman read that. He did a very good job. And then we had Angelo Perez, Tommy. Yep, another good candidate. And now we had Big Dave. Okay, so featuring Dave. Sorry, let's just go with Dave there. But yeah, nice job. So watch out, caution, it is just the y value. You all did a good job of emphasizing the is not, noticing the italics. Yep. And then, of course, caution or cuidado. Just a little Staub trivia. Staub, the only thing Staub knows in Spanish is cuidado piso mojado, from the slippery when wet mop bucket. So anyhow, back to the what we were doing. We have to talk about domain and range. So domain is all the possible x values. Okay, and for these functions, when they're quadratic functions, the domain values are not going to have any restrictions. So they are just all real numbers. You can put any number in for x. If you were to follow the function, let's just say I put this on an xy axis, so like it would be like that, and then you'd have your axis go like that, right? And 0, 5 is the vertex. I can follow this function if I go and drive the vertex again. I gotta get on there. Get over here, you little vertex. All right, so if I take this if I take this vertex and I drive this, I can have any x value I want. I could plug into this function. It's not restricted in the x direction at all. I could put any value in for x. I could put 17,000 in for x, and it would be somewhere way up there off the charts as a y value. All right. So then you might be wondering, well, what the heck? Like domain, why are we even talking about if it's all real numbers? So I'm just going to add a little scratch page in here. And let's just say, and we're doing this in pre-calc right now, we're doing rational functions. So let's say the function was f of x equals x plus 5 over x minus 3. What do you know about dividing by 0? No, dividing by 0. You can divide 0 by something. Here, I'll divide 0. See this in front of me? Watch. If you're listening at home, you'd have to imagine there's nothing in front of me right now. All right, now I'm going to divide it into 3 equal parts. Ready? I'm going to divide nothing into 3 equal parts. Yeah, yeah, yeah. I just did. There's still nothing, right? I divided 0 by 3 into 3 equal parts, and there's still 0. All right, now here, I'm going to take Sydney's phone right here, and I'm going to divide this into 0 equal parts. Okay, you ready? What? Yeah, what? What are you talking about, buddy? So you can't divide by 0, it doesn't work. It's undefined, it's mathematically undefined. So because of that, are there any values for x that x cannot equal? 3. X cannot equal 3 in this case because it would make the denominator 0, and so therefore it would have a restriction in the domain, so that all possible x values would be all values x such that x is not equal to 3. So that's how you could list your domain there, right? So, but for quadratics and for this chapter that we're in here, all of this stuff, the domain is going to always work out, so it's going to be all real numbers. All right, so the domain is all real numbers. The range, however, is going to have some restrictions. So what is the range or all the possible y values? 5 and above. Good. If the 5 is the minimum value, then we can have any number greater than or equal to 5. So in this case, y has to be greater than or equal to the minimum value, which is 5. So that's your range. So your domain for all of these quadratic functions, I'll give you a little hint here, is always going to be all real numbers. There's no restricted value you can put into something and square it. So the domain's all reals. The range is going to depend on whether you have a minimum or a maximum. And in this case, we have a maximum. So that means my y values are going to all have to be less than or equal to that maximum value, which was -2. All right, making sense? Okay, moving on. Whoop, moving on again. Okay, this is just a little more information from the book on maximum, minimum, domain, and range. Okay, now we'll talk about functions that are in standard form. So when they're in standard form and we want to find the maximum or minimum, we need to essentially find the vertex. And to find the vertex, we are going to use our opposite of b over 2a and f of the opposite of b over 2a. Okay, so if we rattle off our a, b, and c, in this case a is 1, b is -6, and c is 3. So the opposite of -6 is +6 divided by 2 times a, which is 2. So that's going to be 3, and then f of 3 is my y value. So I have to put 3 into the function and solve for f of x. So that would be 3 squared minus 6 times 3 plus 3. So 9 minus 18 plus 3, that's going to be -6. So my vertex is 3, -6. What that tells me is my maximum or minimum. If I'm looking at my y, is that a maximum or a minimum? That's going to be a minimum because it opens upward. And so because it opens upward, the vertex down there is the minimum value. So this is going to have a minimum of y equals -6. And the domain and range is going to be, of course, domain is going to be what? All reals. And the range, since it is a minimum, is y is greater than, so we said greater than or equal to 6 negativo. Okay, this next one's kind of a bummer because it has fractions in it. So let's go ahead and grind this one out. I fear no fraction. All right, opposite of b over 2a, that's what I need to find my vertex. Okay, so opposite of b over 2a, and then I'm going to plug that in and find f of the opposite of b over 2a. Opposite of b over 2a, that's going to be -2 over +6. Okay, which you guys should know, huh? Opposite of 2 is -2 over 2 times -3. Yeah, that's a negative. Wait, yeah. Okay, that's a +1/3. Good catch. So f of +1/3 is going to be my y value. So if I clean that up a bit, I have the vertex as an x value of 1/3 and the y value of, now I got to put 1/3 into that and square it and do all that stuff. So let's go ahead and evaluate f of 1/3. This is it. Don't get scared now. -3. You guys know what movie that's from? This is it. Don't get scared now. It's a Christmas movie with lots of traps in it. Austin Powers. 1/9. -3 times 1/9 plus 2 times 1/3 is 2/3 minus 4. Let's get common denominators here. -3 times 1/9, that's going to be -3/9. I'm just going to go this route. I know it's a little redundant, but I know some of you guys might get lost if I reduce that. So -3/9, which reduces, of course, but let's just go in ninths. 2/3 is how many ninths? 6/9. That's funny because I wrote a 6 instead of a 9. All right, 6/9, and then how many ninths is 4? 30. What's 9 times 4? 36 ninths. So add those all together. Don't forget the last one is a negative, so we have plus and negative. What do you get when you add those all together? You get -39 plus 6, -33 ninths. -33 ninths. That's like 3 2/3. So -3 2/3, I believe, which I wrote a 3. Yep, that's correct. Wow, I'm losing a little bit. That is your vertex. So now from that we can list our maximum or minimum. In this case, does this one open up or down? This one opens down, and it opens down because we have a negative leading coefficient. So if it opens down, then my y value is going to be a maximum. So it's going to be a maximum at y equals -3 2/3. The domain is going to be all reals. And the range is going to be what? Here, let me call on someone. Let me call on someone here. Dave.
Y is less than or equal to 3 2/3.
All right, I don't know if you could hear that, but y is less than or equal to -3 2/3. All in favor say moo. Moo. Any opposed? Say bye. All right, so it looks good there. Last page. 25 minutes in. So let's cruise through this now. This has everything we just did, and there's no fractions, so let's rock and roll through this. I'm going to go really fast. Upward or downward, folks? Upward. Okay. It might help you to draw a little picture upwards just to see. Oh yeah, that's going to be a minimum. Minimum or maximum? I'm going to jump down here. Minimum. Okay. What is the vertex? 3, 1. What's the axis of symmetry now? X equals 3. What's the y-intercept? This one gets them every time. It's not 1. The y-intercept is where x is 0. So the y-intercept is the constant when it's in standard form, like over here. That has a y-intercept of -2. But this is in vertex form, so at the y-intercept, x is 0. So what do you get when you put 0 in for x? You get 10. You get 0 minus 3 squared, which is 9, plus 1 is 10. Okay, I'll just show you real quick since I'm on the topic. If I were to multiply that out, I would get x squared minus 6x plus 9 plus 1. So in standard form, it would be, the constant would be 9 plus 1 or 10. So you got to watch out there. I guarantee there's going to be a few mix-ups on the next quiz with that one. Yes. Yeah, but that's only works for standard form. So it's only the constant c when it's in standard form. See that? Because when it's in standard form, you put a 0 in for x, like over here. That's 0. That's 0, and it's always just your constant. But if you put a 0 in for x here, that's not always just 0. See what I'm saying? You know what I'm saying? You picking up what I'm putting down there? You hear me barking, big dog? So minimum value at a vertex of 3, 1, my minimum value is the y value. So that is going to be y is greater than or equal to 1. The domain, of course, we talked about the domain. That's going to be all reals. And the range is going to be y is greater than or equal to 1. I already said that. I'm starting to malfunction a little bit. Okay, so there's all your information. So now you can go ahead and put that down on paper. We have an axis of symmetry at 3. So we go 1, 2, 3. We go right here. There's my little axis of symmetry. My vertex is on there at 3, 1. So that's going to be like right there. It's going to open upward. It's going to have a y-intercept of 10. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's up there. So I got that one there. If I reflect that over here, it'd be over at 6, 10. And then I can draw a happy little vertex like Bob Ross would right there. Happy little vertex in there. Happy one. Okay. Nobody watches these videos. That's a good point. If you have trouble sleeping, don't use Ambien or any of those sleeping aids. Just dial up one of these videos. Nestle in and you will be right to sleep. Upward or downward? Upward. Good. Axis of symmetry, can't just look at it anymore. I have to calculate opposite of b over 2a because it's in standard form. Opposite of b is going to be -6 over 2 times a is 2 times 3 is +6. That's going to be x equals -1. My vertex then is going to have x value -1. When I put -1 in for x, I'm going to get 3 times -1 squared plus 6 times -1 minus 2. That's going to be +3 minus 6, which is -3 minus 2, which is -5. So -1, -5 is my vertex. Is that a max or a min, everyone? It's a minimum because it opens upward, so it's a minimum. So my minimum is going to be y equals -5. The domain, folks, is all real numbers. That's all, folks. All real numbers. And the range is going to be any value y greater than or equal to -5. Sketch that graph. So we go over to my axis of symmetry at -1. Do a little imaginary little dotted line there. The vertex is going to be 5 down on that line. So 5 down is going to be like somewhere down there, I guess. We just call that 1, 2, 3, 4, 5. That actually was 6. It opens upward, and it has a y-intercept of -2. So the y-intercept of -2 is like up there. It's going to open upward. I can reflect that -2 on the other side and make a nice little happy little sketch right there. Whew. Okay, 30 minutes. Wow. If you are going to be watching this, I bet you fast forwarded through. There's your assignment. All right, notice that for problems 8 through 10, you have to do all A through H, and then the rest you don't have to graph it or put the y-intercept. All right. Cheers. Have a good day.